Okay, so welcome to Mastermind Scholars Education and Alliance. We are going to deal with probability lesson 9, which talks about the addition law itself. Now we are going to, Mastermind, we always dream, we believe, and then we achieve excellence. Now, let's get to addition law probability. Now, for the addition law probability, you see, law probability states that it's actually used to calculate the probability that at least one or two more events occurs. At least greater than or equal to, right? So at least means one or two events are happening. Now, it applies when you are considering the likelihood of event A or event B or event C happening, or they happening together in that regard. Now, there are two types. Actually, we have addition law for mutually exclusive events, and we have addition law for non-mutually exclusive events. Now, for the addition law of mutually exclusive events, is used to calculate events that cannot occur at the same time. Can you understand the word mutually exclusive? It can't happen at the same time. So mutually, it's not existing. Like they don't exist on the same grounds in that regard. So mutually exclusive events. The formula is given by the probability of A, which represent the first event, union B represent the second event, is equal to probability of A plus probability of B, because they are mutually exclusive. You say A and B are occurring, then we are going to consider A and B occurring, addition of the A and B occurring. Now, when we are using addition, we mostly talk about finding stuff that you use the little letter or, this or this occurring. You get it? Did you just see it in event A or event B or event C? You get it? So consider that very well. Now, here A union B means A and B, A or B happens. A or B. So in probability, when you hear or, it means we are going to add the two probabilities. Take note of that. Then we get to addition law for mutually exclusive event. So when events cannot occur at the same time, so I think it repeats itself. Example of mutually exclusive event, things that cannot happen at the same time. Just watch here. So they are events that cannot happen at the same time. Tossing a coin. Event A, you toss a coin and get a head, and you toss a coin and get a tail. Because you can't get both a head and tail in a particular event, it means that it's mutually exclusive. You can't literally toss a coin and get an A and at the same time get a B at one toss. It's not possible. So it's mutually exclusive. When you roll a die, the event A, you get a 3. Event B, you get a 5. One die roll can only show one number, and you can't roll a die and get two numbers at the same time. Because of that, each event is mutually exclusive. They can't occur both together. Now, event 3, drawing a card from a single deck. Red card, black card, they can't both occur. And the last one, student grades. I'm giving you a couple of examples, right? So, students get a grade A and student getting a grade B. The students cannot get A and B at the same time. And that is why these are the things we are talking about as mutually exclusive. When you see these examples listed, you should understand that questions on mutually exclusive events on addition are going to be asked. So now questions on mutually exclusive events on addition. So a die is rolled. What is the probability of getting 2 or 5? Well, when a die is rolled, it's mutually exclusive and it cannot occur. 2 and 5 cannot occur on the same ground, on the same toss, or in the event. And so they are mutually exclusive. They happen independently, right? So solution A is getting to its probability P of A is equal to 1 over 6. Because you toss a coin, you roll a die, you are going to get 1. Of getting a 2, you're going to get 1 over 6. Because the sample space is 1 for the toss, and the total possible outcomes are 6, so 1 out of 6. And then for getting a 5, 1 out of 6 as well. So what do you do? Since they are mutually exclusive and a die shows only one number at a time, you can have the formula probability of A union B is equal to the probability of A plus the probability of B. And what happens? You get 1 out of 6 in that regard. and that 1 out of 6 plus 1 out of 6, and that gives you 1 out of 3 when you solve them simply. Now go to question 2. A coin is tossed once. What is the probability of getting either a head or a tail? So when we toss a coin, you know it's mutually exclusive because you are literally not going to have two of the parts showing at the same time. So probability of A is 1 over 2. Probability of B is also 1 over 2. And what do you have? Since A and B cannot happen together, they are mutually what? Exclusive. So probability P of A plus P of B, and 1 is 1 over 2 plus 1 over 2. That's half plus half is 1. Now let us deal with questions on mutually exclusive events on addition. I think question 3, picking a card from a deck. So a single card is drawn from a standard deck of 52 cards. What is the probability of getting either a king or a queen? So for getting a king, it's for all out of the 52 cards. Getting a queen, there are four queens out of the 52. And so because you cannot draw a queen and a king at the same time, you are going to have it as a mutually exclusive event. So you are going to have 4 over 52 plus 4 over 52, which gives you 3 over 30. And I think the last one, selecting a marble. So a bag contains 3 red marbles and 5 blue marbles and 2 green marbles. If one marble is drawn at random, what is the probability of getting either a red marble or a green marble? So you are getting either a red or a green marble. So probability of getting a red is 3 over 10, and that of getting a green marble is 2 over 10. A marble cannot be red and green at the same time. So they are mutually exclusive. And that will give you 3 over 10 plus 2 over 10. That gives you 5 out of 10. And we are done. Now, example of non-mutually exclusive. Non-mutually exclusive event is the event that actually in a draw, you can have 2 happen at the same time. So 2 events are mutually exclusive if they can happen at the same time. They can overlap. So let's look at some examples. When event can occur at the same time. So the formula uses this. So A union B is equal to probability of A plus probability of B minus the common grounds, so that we don't count it twice. We want to count it just once. The probability of A intersection probability of B. Take note of this formula very carefully. This formula. Take note of it. Take note of it very carefully. Now, let's look at a typical example. Drawing a card. Now, event A, drawing a red card. So drawing a red card and drawing a king. So event A, you draw a red card, and in event B, you draw a king. What can happen is that the card, like the king of hearts or the king of diamond, is both red and a king. It can be red and a king. You can draw a card and literally red and also a king as well. It overlapped, right? So what do? These events can occur together. Because of that, it's not mutually exclusive. Because of that, let's look at another example. A student scale. Student event A, student in good in mathematics, and then event B, student good in science. You can have a student that is select a student that is good in math and good in science at the same time. So it's also called non-mutually exclusive. It can overlap. At a draw, just a draw, 2 things can happen at the same time. Now choosing a number from 1 to 10. Event A picking an even number, and event B picking a multiple of 3. So with that, the number 6 is both an even number and a multiple of 3. So event A and B happen together. They can happen together. You can just pick up a draw from the 1 to 10, and it's literally an even number and at the same time multiple of 3, which 6 is a typical example. And so it's not mutually exclusive. Look at an employee of a company. You choose someone from the IT department, and you choose someone who is under 30 years old. And you can have someone who is IT and still under 30. Because of that, it's not mutually exclusive. I think the examples are ample for you to understand. Football, basketball, a student might play both, and it's non-mutually exclusive. Let's look at questions that include non-mutually exclusive. In a class of 50 students, 30 like apples, 28 like bananas, 15 like both apples and bananas. What is the probability that a randomly chosen student likes apples or bananas? So probability of A is 30 over 50 because 30 outcomes out of the total outcome, which is 50 of the class. Then probability of B, which is bananas, is 28 over 50. Now, intersection is students that eat both apples or like both apples and bananas are 15 over 30. So in the use of general rule, you know this is overlapping. Students like apples at the same time like bananas. Because they're overlapping and they can happen together, they are going to use this general rule. All right. So we use the general formula, this. We subtract the overlapping point, and then we actually have our work now very perfectly done. So we have 30 over 50 plus 28 over 50 minus 15 over 30, and we have 43 over 50. Just like that. Look at example 2. A number is chosen at random from 1 to 10, 1 to 20. What's the probability that it is a multiple of 3 or a multiple of 4? So solution, we have multiple of 3 to be 3, 6, 9, 12, 15, and 18, which are 6 numbers. We have multiple of 4, which are 4, 8, 12, 16, and 20, which are 5 numbers. So then, common to both, we have an LCM between 3 and 4, numbers that are multiple of 3 and multiple of 4 at the same time. And 12 is a typical example. That is one number. So because there is an overlapping point, we use the rule, the general rule. What's the general rule? P of A union B is equal to P of A plus P of B minus P of A intersection B. That's the general rule for non-mutually exclusive. So we get the answer to be 10 over 20, which simplifies to become 1 out of 2. So that is it.